Do you wonder what the difference is between OpenMP and MPI? Are you sometimes afraid of embarking on this weird modeling study with lots of equations? Do you want to know what kind of assumptions go into all these fancy modeling studies you're reading? Are you confused about what constitutes a benchmark or an analytical solution? Do you want to figure out what happens below our feet? We've got the answers for you. Hello, I'm Iris van Zelst and I'm a postdoc at the German Aerospace Center in Berlin, Germany. I mostly study the geodynamics and seismology of the Earth and the planets, and I hope I can enthuse you about these topics as much as I like them. Geodynamic modeling uses computer models to study the motions of the Earth and other planets as well, and compare and link to many other geosciences disciplines to create a holistic picture of the large-scale happenings inside the Earth, which can also have, of course, a direct effect on humans through natural hazards such as earthquakes. Geodynamic modeling is important because when we are trying to understand the Earth and its large-scale happenings, we don't have any direct data. We can't really look very deep below our feet. We can only maybe look directly for a kilometer or 10 or so, while the Earth is much bigger than that. So in order to actually learn something about the large-scale dynamics, both in space and time, we need geodynamic modeling to tell us what is at least physically possible. This paper presents the basics of geodynamic modeling for first-time and experienced modelers and collaborators and reviewers from all kinds of diverse backgrounds so that you can regain a solid understanding of geodynamic modeling as a whole. We noticed that with the growing powers of computers, there is much more interest in the potential of geodynamic modeling in understanding our Earth. So what we are trying to do is helping you with understanding these geodynamic models, because we notice that some people do not have the background to fully appreciate all the assumptions that go into these models. So our papers set out in a really easy way the equations, the computational jargon, and the best practices to help you on your geodynamic modeling journey. Beyond looking at geodynamic modeling in its own niche, we are also trying to be aware of all the other disciplines in geosciences and specifically geophysics. So what we try to do in our paper is point out all the synergies of geodynamic modeling with other disciplines such as seismology, tectonophysics, and geodesy. When you have read our paper, we hope that you feel comfortable using the equations and using the computational methods that are used in geodynamic modeling. Hopefully, you'll be aware of the assumptions that go into the models, and you'll know how you'll be able to interpret your models correctly. And of course, use the state-of-the-art best practices in order to make your study reproducible for everyone who wants to try it.